Introduction.
Good morning, teacher.
Good morning, students. Today we will learn about alcohols, phenols and ethers.
Sir, what are alcohols?
Alcohols are compounds in which one or more hydrogen atom in an alkane has been replaced by hydroxyl group. What is hydroxyl group, teacher? The hydroxyl group is a functional group consisting of a hydrogen atom covalently bonded to an oxygen atom. Now, can anybody tell me what is phenol?
Yes, teacher. Phenol is an organic compound where one hydrogen attached to a benzene ring is replaced by a hydroxyl group.
Very good, Sunil. In this lesson, we will learn about alcohols, phenols and ethers. Objectives. At the end of this lesson, you will be able to classify alcohols, phenols and ethers, discuss nomenclature of alcohols, phenols and ethers, describe structures of functional groups, describe the methods of preparation of alcohols and phenols, describe physical properties of alcohols and phenols. Classification. Classification of alcohols, phenols and ethers. Mono, di, tri or polyhydric compounds. Alcohols and phenols are generally classified according to the number of hydroxyl groups present in the molecule. The alcohols containing one hydroxyl group are termed monohydroxy, with two hydroxyl groups as dihydroxy and with three hydroxyl groups as trihydroxy. Phenols containing one hydroxyl group are termed as monohydric, with two hydroxyl groups as dihydric and with three hydroxyl groups as trihydric. Classification. Monohydroxy alcohols can be subdivided on the basis of hybridization of the carbon atom to which the hydroxyl group is attached. Compounds containing sp3 hybridized carbon atom bonded with hydroxyl group. The hydroxyl group in alcohol is attached to sp3 hybridized carbon atom of alkyl group. They are further subdivided into primary, secondary and tertiary alcohols. Allylic alcohols. Those alcohols in which hydroxyl group is attached to single bonded sp3 hybridized carbon next to carbon-carbon double bond, that is, to allylic carbon, are called allylic alcohols. Benzylic alcohol. Those alcohols in which hydroxyl group is attached to single bonded sp3 hybridized carbon next to aromatic ring are called benzylic alcohols. Classification. Compounds containing sp2 hybridized carbon atom bonded with hydroxyl group. The hydroxyl group in alcohols attached to a carbon-carbon double bond, that is, to a vinylic carbon. They are also known as vinylic alcohols. Ethers. Ethers are organic compounds which can be represented by the general formula ROR-. The groups R and R- may be alkyl or aryl, either same or different. If the alkyl or aryl groups are same, then ethers are said to be symmetrical, and if alkyl or aryl groups are different, then ethers are said to be unsymmetrical. Nomenclature. Alcohols. Alcohols can be named either by using common name system or by IUPAC system of nomenclature. In common name system, alcohol is named by listing the alkyl group and adding the word alcohol. In IUPAC system, pick out the longest continuous chain to which the hydroxyl group is directly attached. The parent name of the alcohol comes from the alkane name for the same chain length. Drop the E ending and add OL. Number the parent chain so that the carbon bearing the hydroxyl group has the lowest possible number. locate and name substituents other than the hydroxyl group. Example: 2-methyl-2-propanol. In cyclic alcohol, the hydroxyl group is assigned the C1 position. The second substituent then gets the lowest number. For example, 2-ethyl-5,5-dimethyl-cyclohexanol. Nomenclature. Phenols. Phenol is hydroxybenzene. Phenol is a common name and is also the IUPAC approved name for the simplest member of the phenol family of compounds. The name phenol is derived from a combination of the terms phenyl and alcohol. The substituents on the benzene ring are indicated by suitable numbers. For example, hydroxyl derivatives of toluene are ortho, meta, and para-ceresols. According to IUPAC nomenclature, these are named 2-methylphenol, 3-methylphenol, 4-methylphenol respectively. One more example is the benzene diols also have common names. Nomenclature. Ethers. The common names of ethers are derived by naming the two groups alkyl and or aryl linked to the oxygen atom in alphabetical order followed by the word ether. In case of symmetrical ethers, prefix di is attached before the name of the alkyl or aryl group. According to IUPAC system, ethers are named as alkoxy alkanes. The smaller alkyl group constitutes the alkoxy group, for example OR, whereas the bigger group, example R-, gives the name of the parent alkane. Structures of functional groups. Structure of ROH. Both the carbon atoms of alkyl group and oxygen atom of hydroxyl groups are sp3 hybridized. For example, methanol. The COH bond angle is slightly less than tetrahedral angle, that is 109 degree 28 minute, due to repulsions between lone pairs of electrons of oxygen atom. The CO and OH bonds are polar because of high electronegativity of oxygen atom. Structure of phenol. In phenols, CO bond is formed by overlap of sp2 hybrid orbital of carbon with sp3 hybrid orbital of oxygen. The COH bond angle in phenol is 109 degree. The CO bond length in phenol is 136 picometer. The CO bond length in phenol is shorter than that in methanol due to the conjunction of unshared pair of oxygen with the ring, which imparts partial double bond character to the CO bond. Structure of ethers. The hybrid orbitals assume tetrahedral arrangement around oxygen. However, the COC bond angle is greater than 109 degree 28 minutes due to repulsive interactions between alkyl groups. Bulkier the alkyl groups, more will be repulsive interaction, and consequently larger will be the deviation in the angle. For example, in dimethyl ether, the bond angle is 117 degree. Thus, ethers have bent shape and therefore have resultant dipole moment. Alcohols and phenols. Preparation of alcohols. From alkanes. By acid catalyzed hydration. In the presence of acid, alkanes react with water and form alcohols. Alkane reacts with water in the presence of acid and then forms respective alcohol. Unsymmetrical alkanes follow Markov-Nikov's addition. Mechanism. This reaction involves the following steps. Step 1. The alkane accepts the proton by electrophilic attack of hydronium ion to form a stable carbocation. Step 2. The carbocation reacts with a molecule of water to form protonated alcohol. Step 3. Transfer of a proton to a molecule of water leads to the formation of alcohol. From alkanes. By hydroboration oxidation. Diborane reacts with alkanes to give trialkyl boranes as addition product. Trialkyl boranes are then treated with hydrogen peroxide in presence of alkali when they undergo oxidation and hydrolysis to give an alcohol. Preparation of alcohols. From carbonyl compounds. By reduction of aldehydes and ketones. Aldehydes and ketones are reduced to primary and secondary alcohols respectively by reacting them with hydrogen gas in the presence of finely divided metal such as palladium, platinum or nickel. Alcohols can be prepared by the reaction of ketones with sodium borohydride or lithium aluminium hydride. From carbonyl compounds. By reduction of carboxylic acids and esters. Carboxylic acids can be reduced to primary alcohol by reacting it with lithium aluminium hydride. Lithium aluminium hydride is mixed with acetic acid along with water, which forms ethanol. Esters can also be reduced to alcohols by treating them with hydrogen in the presence of lithium aluminium hydride. On treating esters with hydrogen in the presence of lithium aluminium hydride, it forms alcohol. Preparation of alcohols. From Grignard reagents. Alcohols can be prepared by the reaction of Grignard reagent with aldehyde and ketones. Grignard reagent reacts with ethanol to form product which decomposes with dilute HCl to give propane, 2OL and hydroxymagnesium bromide. Grignard reagent reacts with propanone to form product which decomposes with dilute HCl to give 2-methyl-propan, 2OL and hydroxymagnesium bromide. Preparation of phenols. From haloranes. Heating chlorobenzene with concentrated sodium hydroxide solution at 300 degrees Celsius and at 300 atmospheric pressure results in the formation of sodium salt of phenol, which is acidic medium, liberates free phenol. Concentrated NaOH is mixed in chlorobenzene solution at 300 degrees Celsius and at 300 atmospheric pressure results in the formation of sodium phenoxide, and then by providing some acidic medium, it gives phenol. From benzene sulfonic acid. Sulfonation of benzene with oleum gives benzene sulfonic acid, and then by fusing benzene sulfonic acid with sodium hydroxide at 300 degrees Celsius, which leads to the formation of sodium phenoxide, and then on acidification, it gives phenol. Benzene is sulfonated by using oleum, and it forms benzene sulfonic acid, and then on heating the solution with sodium hydroxide, it forms sodium phenoxide. On acidification of the solution, it results in phenol. Preparation of phenol. From diazonium salts. A diazonium salt is formed by the treatment of an aromatic primary amine with nitrous acid at 0 to 5 degrees Celsius, and then diazonium salt is hydrolyzed by warming with water, which gives phenol. Aniline is treated with nitrous acid at a temperature of 0 to 5 degrees Celsius. It results in the formation of benzene diazonium chloride, and then by adding warm water it forms phenol, nitrogen and hydrochloric acid. From cumene. The oxidation of cumene results in the formation of cumene hydroperoxide, which on hydrolysis in acidic medium produces phenol and acetone. Physical properties. Boiling points. Alcohols and phenols have higher boiling points than other compounds such as ethers, halolcanes and halorenes of comparable molecular masses. Alcohols and phenols boiling point increase with increase in the number of carbon atom because van der Waals force increases. In alcohols, with the increase of branching in carbon chain, the boiling point decreases. The reason is that when branching increases, van der Waals force decreases due to decrease in surface area. The hydrogen atom in OH group of alcohols and phenols bonded to an electronegative oxygen atom, therefore it is capable of forming hydrogen bond. Solubility. Alcohols and phenols are generally soluble in water because both alcohols and phenols form hydrogen bond with water molecules. Did you know? Alcohols may be liquids or solids according to the size and complexity of the molecule. The alcohol produced naturally in the fermentation process and consumed as part of alcoholic beverage is called ethanol. On consumption of alcohol, the effects of alcohol include poisoning and changes in the functioning of human nerve cells. Summary. Let us summarize what we have learned. Alcohols and phenols are generally classified according to the number of hydroxyl groups present in the molecule. The alcohols in which hydroxyl group is attached to single bonded sp3 hybridized carbon next to carbon-carbon double bond, that is to allylic carbon, are called allylic alcohols. The alcohols in which hydroxyl group is attached to single bonded sp3 hybridized carbon next to aromatic ring are called benzylic alcohols. Vinylic alcohols are those in which hydroxyl group is attached to a carbon-carbon double bond, that is to a vinylic carbon. Alcohols can be named either by using common name system or by IUPAC system of nomenclature. Phenol is a common name and is also the IUPAC approved name for the simplest member of the phenol family of compounds. According to IUPAC system, ethers are named as alkoxyalkanes. Alcohols can be prepared by acid catalyzed hydration, by hydroboration oxidation, by reduction of aldehydes and ketones, by reduction of carboxylic acids and esters, and from Grignard reagents. Phenols can be prepared from haloranes, benzene sulfonic acid, diazonium salts, and from cumene. Alcohols and phenols boiling point increases with increase in the number of carbon atoms because van der Waals force increases. With the increase in branching in alcohols, the boiling point decreases. Generally, alcohols and phenols are soluble in water.